which is a kind of vector. Okay, so I need you guys to remember vectors very, very briefly. This is a vector. A vector is made of two things, which are a magnitude, which is kind of this length. Right? Magnitude. And where am I getting the direction bit from?
What's most electro?
From
That's really just me kind of thinking arrow at this thing,
pushing
right?
the dot around.
Okay, so a vector is made of two things, a magnitude and a direction. The use of vectors in physics class is mostly this thing called a free body diagram. You guys know anything about free body diagrams? No? Cool. Let's learn very briefly free body diagrams. So here I want to envision you on the floor. You should be able to envision this really well. I'm playing this part. I'm the stick figure, and the flat thing is the floor.
Nice.
What forces are acting on me as the stick figure?
Gravity.
Gravity.
Yeah. I have gravity pulling down on me, right?
Your own weight machine.
Okay. Gravity acts on my middle.
Acts on your center of gravity.
Yeah, my middle. My center of gravity is probably, I don't know, right in here-ish. What am I basically pointing at?
Hopefully your belly button.
Yeah, pretty much your belly button. On men, it can tend to be a little bit above. On women, it tends to be a little bit below, but that's neither here nor there specifically. Think belly button-ish. Okay. So gravity is pulling down on my belly button. How hard is gravity pulling down on my belly
I
button?
don't know.
Your knees,
force
your
of
weight
gravity
is
is.
Okay, so first things first, I think we maybe need to know this. Force is mass times acceleration. Acceleration is a vector. It has a direction. You can be accelerated, right?
Yeah.
That was this way. And then actually that way.
Yeah.
You guys see that?
Stop. Yeah.
When I kind of did that little hop, right? I was accelerated to the left by me pushing off with my back foot, right?
And you were stopped by your right.
And then I was accelerated in the opposite direction by my front foot when I hit the ground. You guys see that? So there are kind of two force body diagrams going on. Okay, so forces, mass times acceleration. In this case, I have a force of gravity acting down on me. That's by the acceleration due to gravity times my mass. I'm going to call that G, and I'm going to put a little vector hat on it to indicate that it's pointing down. You guys good with this? Okay. What other force is acting on me? Why am I not accelerating down?
Because the ground is pushing back. The ground is pushing back.
Yeah, because there's also a force upwards due to the ground. What would you call that?
Normal force.
Opposing.
Yeah, nice. So if you've taken a physics class, you might call that the normal force. Right? And what do I know? I know personally in this picture, right, I am not accelerating downwards. You guys see that?
The normal force and the gravitational forces.
So I know that if I take the normal force and add the gravitational force, I get no acceleration, right? So that's 0 as a vector. 0 as a vector is a little weird because I told you these things have a magnitude and a direction, right?
You
Zero's
can-
got, what's the magnitude of the 0 vector?
It's 0.
0. What direction does it point in?
0.
That way.
Who cares? Right? Pick any direction. It doesn't matter because it doesn't have any length, right? In this case, I might think, okay, that's a 0 up vector, right? Because I'm not accelerating up.
And you're not accelerating.
And I'm also not accelerating down. So maybe down would be another good choice for where does the 0 vector point. You guys with me on that? So what I found out is that the normal vector and gravity counteract one another, right? So I know I could say that the normal vector is minus the gravity vector. You guys with me on that?
Could you say the gravity is minus the n vector?
Yeah, sure.
Same.
Gravity is, or another thing, right, is you could write gravity is minus the normal vector. It's probably easier for me to calculate gravity that make sense?
Mhm.
So that's why I'm preferring this one. But whatever. You guys good with this? Okay. Next thing's next.
What is gravity?
No, we're not doing that question. That's too big a question. What is gravity and how does it work, or just no? Gravity works. You can get out a step ladder and some lead and like figure out how gravity works a little bit. But I'm not going to tell you any of that right now. That's like go to physics class. Okay?
Okay.
So here's the next thing I want you to kind of think about. That was one situation, right? Easiest situation I have to deal with, me standing in a room. So here's another situation that I might have to deal with. Here's me standing on a hill. Right?
It's a very steep building.
Do you believe you could stand on such a slope?
Yeah.
Depending on what shoes I have on,
Depending
and what the slope is made of.
Good. Depending on what the slope is made out of, I
Are we
think
talking,
probably.
we talking ice, or are we talking like pavement?
So I'm going to go pavement for right now.
Okay, I can do that.
And I claim that driveways around here get a lot steeper than this anyway.
Oh yeah, I could crawl.
I don't know if it's steeper than 45 degrees. So that's a little excessive.
Yeah, so the 1-for-1 slope, right, is a little bit steep. Okay. Let me think here. What force is acting on me as a person?
Gravity.
Okay, there's gravity acting on my belly button, right? And that's pulling me down with the force of gravity.
But there's also the ground that's pushing out.
Okay, and now the
90 degrees
ground's
away from
pushing
the
out,
ground.
right? But the ground's not pushing up.
It's pushing,
Perpendicular. to
pushing
the
45
slope.
degrees out.
The ground's pushing this way. So I'm going to call that, actually I'll just call that N again, because that was a good vector choice. So we'll call that N.
Friction.
And then what's keeping you from sliding down the hill
Friction between your shoes and
is the friction between your boots and the ground, right? So there's also this one, which we'll call
Mu.
yeah.
mu.
That's my physics class.
Cool. All right, so I'm going to need to draw that I'm going to need to blow that diagram up a little bit for everybody to see. Okay. 45 degrees. Guy. Gravity is going down. Mu is going up with the slope. This is pushing out with an angle. Cool?
I'm done with my class.
Cool. You can dump it, just leave it right where you are and take it. Thanks. Okay, so what do you know about standing on a hill? If you're standing on this hill,
You lean forward.
no, stop. If I'm standing on the hill like this, right? Am I sliding down the hill? Am I accelerating towards somewhere?
No.
You may feel like at some point you might, but
Yeah, at some point I might slip, but if I assume that I'm actually standing there, right? Then I know my forces add to
Zero.
0. So I can write down a little equation, right? And my equation is going to be 0 as a vector, right?
Can you define water or something?
Is
No.
the gravity
No, no,
plus the friction plus the normal force. You guys all with me on this? Cool? Yes?
Yeah.
Okay. That means, right, that gravity adds up to the opposite of mu and n.
Yes.
You guys see that?
Negative G equals.
So negative g is mu plus n.
And so G is equal to negative mu plus negative. Or minus n.
Basically, the way that you ought to think about that here, right, is the gravity vector pointing down has to be balanced out by these guys.
By a negative force.
Right? So if I reflect the gravity vector up here, that's a minus gravity vector there. You guys with me on that? And that should add up to n and mu stuck together. So if I move mu to the end of n, that would look like this. guys all with me on this picture?
Oh, because it's a parallel. Yeah.
Okay, cool.
I know, it's-
You've done this a million times in physics? Yeah. This is pretty basic physics, right?
And that's just the way
Okay.
we do it without.
Yeah, and I haven't really done any math yet, right? I've just drawn a free body diagram, which is just like basically a useful skill I want you all to have. So now I should be able to figure out something about the normal force and friction, right? You guys envision doing some math to figure this out? Maybe? No?
Perpendicular line from G at vertex there.
I see a right triangle.
Oh, look at that. There's a right triangle here, maybe? Why is that a right triangle?
Oh, because,
Because
the slope of friction and, the slope of your normal force are is perpendicular to each other, which is 90
But
degrees.
why, dude? Why?
because ground is typically
Oh,
Like, why should they be perpendicular?
Because
That's the thing
normal
that
force-
everybody says in physics class, but I want the why.
well, friction obviously goes along with the slope,
Yeah, friction's parallel to the slope, right?
and normal force seems to be perpendicular. to the
And
slope.
normal force has to be perpendicular to the slope, so those two things have to be perpendicular. You guys see that? Okay, so now maybe we could figure something out about this triangle. How would we figure something out about that triangle?
The Pythagorean theorem, I would say that n squared plus m squared is equal to g squared.
Okay, so we could write down something about the Pythagorean theorem. We could say like the length of mu squared plus the length of n squared has to equal the length of g squared. That's true.
what are those lines?
They're like absolute value bars, but for vectors.
Wow, I'm tired.
An absolute value bar tells you how far from zero a number is, right?
Right?
So absolute value bars tell you how long a vector is.
Absolute value.
I'm going to call them magnitude bars later, but or
Mag bars.
norm.
Some mag bars.
Mag bars? Yeah.
Mag bars.
So this really says the magnitudes squared add up, right? Because Pythagorean theorem applied to triangle, right? You guys with me on that? Okay, I think the 45 degrees of your slope should appear somewhere up
Yes.
here.
You see.
Anybody
And
see
one
it?
of those things is
45,
45, and so is the other one.
Yeah, basically everything in this picture is a 45 degree angle, right?
Yeah.
So this one particularly right here,
Which also means the other one on the inside.
right? So this is a 45 degree angle, and so this has to be a 45 degree angle. 45 is easy because I don't have to figure out which one's which,
Yeah.
right? But all of these are 45 degree angles.
Except
You guys see that? So if they're all 45 degree angles, then we could maybe decompose into parts or something. Yeah, maybe.
if we can do some trig.
Okay, so I want you to know that we could do that trig. And now I want to apply this to a slightly different situation.